Physics Penguin.
Welcome to Physics Penguin's Guide to Electrical Resistance. In this video we'll be following this simple format. What is resistance? Where does the idea come from? And how can we measure it in a circuit? There is a worksheet that follows along with this video. You can access it using the link in the video description. Try the questions from the sheet, and then in the final section of the video I will go over the answers. Resistance is a slightly strange idea. It is a measure of how hard it is for electricity to flow through something. For example, rubber Wellington boots are very hard for electricity to travel through, so we can say that they have a high resistance. A thick copper wire is easy for electricity to travel through, so it has low resistance. So why is resistance a strange idea? Well, normally we talk about how good something is at doing its job. How fast does that car move? How far did that penguin swim? But resistance measures how bad a material is at letting electric charge flow through it. That's a bit like asking, how slow is that car? And how far short of Antarctica is that penguin? Just bear in mind, big resistance means lower current. Small resistance means higher current. Measuring resistance can be done directly using a device called a resistance meter or ohm meter, but it's often calculated using a law of physics. So here's the law. V equals IR. What? Well, that's it. It's called Ohm's Law, but you need to learn what the letters mean and how to use it. V is potential difference. You'll notice that the word potential difference does not include the letter V. That's because it's also called voltage by most people, but not Physics Penguin, okay? Potential difference is measured in volts. I is current. You'll notice that the word current doesn't include the letter I. That's because it comes from a French phrase for current, not the English word. Sorry about that. Current is the electric charge per second and is measured in amperes, or amps for short. R is the resistance. It is measured in units called ohms. The only problem here is if you shortened ohms down to one letter to be a unit, O looks like 0. So did you mean 6 ohms or 60 and you forgot to write the unit? For that reason we use a Greek capital letter omega, which I think looks like somebody's head and shoulders. How can you measure it in a circuit? Well, use the formula. So V equals IR, so if we want R, resistance, then we will need to know that V, potential difference, and I, current. So we just need to measure these with a voltmeter and an ammeter. Take a look at this circuit. So we have a cell and we have a bulb, very original. If we slap in a voltmeter across the bulb, we can measure the potential difference across it. In this circuit, that is pretty much the same as the PD of the cell. Current needs an ammeter adding into the circuit. Notice that the current flows through the circuit, but the PD is measured across something. So let's take a look at the readings. Well, the voltmeter reads 6V, 6 volts. The ammeter reads 1A, 1 amp. Now use the formula. V equals IR. So 6 equals 1 times R. Something times 1 makes 6. What could it be? It's 6, okay, it's just 6 ohms. The worksheet asks you to place ammeters and voltmeters in the circuits and use this formula. So pause the video now and try the questions. When you're done, restart and see how great you are. Pause the video. Okay, let's go through the answers now and see how well you did. Question 1. So that was a 12 ohm resistor has a current of 2 amps. What is the PD across the resistor? This is a calculation question with resistance R, current I and PD V. So we need to use the formula V equals IR, Ohm's law here. So V equals 2 amps times 12 ohms. 2 times 12 is 24. So the potential difference must be 24 volts. Let's try the next. Question 2. So the circuit below uses a variable resistor, a resistor that can change its resistance, and a 5-volt battery as well as an LED, a light-emitting diode. Assuming the LED and battery have 0 resistance, there's a little picture of it, the variable resistor has been set to 1000 ohms. How much current is in the circuit? And the LED needs 0.1 amps or more to light up. If the resistor is set to 600 ohms, will the LED light up? Well, let's look at the circuit. There are 3 components in a single loop. This is a series circuit. We have the PD, 5 volts, and we're looking to work out current. So Ohm's law is going to help. V equals IR. There are 2 problems. We need the total resistance of the circuit, not just the resistance of one part. And we also don't want PD, V. So we need to rearrange the formula. Oh dear. Happily, the first problem is easily fixed. The question tells you to assume that the LED and battery have a resistance of 0. The total resistance must just be from the variable resistor, so that's 1000 ohms. Now the formula. Well, V equals IR and we want I, the current. We need I on its own on one side of the equation, but it's being multiplied by R at the moment. An equation will work if you always do the same thing to both sides of the equal sign. So to get rid of the times R, let's divide by R. If you multiply by something and then divide by the same number, you end up back where you started. So in this case, V equals IR. So V divided by R equals I when you divide both sides by R. V equals 5 volts and R is 1000 ohms. So we have to divide 5 by 1000, which gives 0.005 amps or 5 milliamps, because 1,000th of an amp is a milliamp. The second part is similar, so we can use the same formula. This time V is 5 volts and R is set to 600 ohms. So let's use I equals V over R. 5 divided by 600 equals 0.008333 recurring. The question asks if this is enough to light the LED. Sadly, it is still less than the 0.01 required, so the LED remains off. Oh dear. Question 3. Calculate the missing potential differences, currents and resistances. And then there's a sort of a table thing with question marks in it. This is quite good practice with Ohm's law, so let's give it a go. Well, in the first line, V equals IR, so all we need is going to be V equals 0.025 times 550 equals 13.75 volts. In the second line, we need I, so we'll take V equals IR, but divide both sides by R to give us I equals V over R, which in this case is 12 over 1500, which makes the current 0.008 amps. In the final line, take V equals IR and divide both sides by I to give the formula V divided by I equals R. So 4 divided by 0.01 equals 400 volts. Easy. Question 4. We have to redraw the circuit from question 2, but add a voltmeter to measure the PD across the battery and an ammeter to measure the current through the LED. Okay, so we start with the diagram you were given. The rule here is that ammeters go in series. So we need to draw an A in a circle, but we can just add it anywhere in the circuit. Voltmeters measure PD across a component though, so we need to add the voltmeter in parallel, like its own little short circuit across the part that you want. In this case, the battery. Ta-da! Well, that's it. If you need to recheck anything, go back and watch the video again. But if you completed the sheet, well done. Why not subscribe to be notified of the next video in the series going up? Well, that's it from Physics Penguin. Ta-da!
Physics Penguin.